Hello and welcome to today's class. For today's class, we'll be trying to resolve the tensions on four masses as shown in this system here. But before we do this, please make sure you've watched our previous classes on inclined planes so that you can have a concept or an idea of how it's done. I'll leave a link to our previous classes on inclined planes in the description of this video. All right, now back to our question. Let's take the question here. The question says, consider the diagram below with masses M1, M2, M3, and M4 hanging over a free-moving pulley on an inclined frictionless plane. Suggest a direction for the motion of the masses and use the information to, number one, set up the correct equation of the forces acting on the systems. Also, we'll take them one after the other. The first thing here says we should suggest a direction for the motion of these masses on this inclined plane. Now, how do we suggest a direction? To get your direction, we said from our previous classes that it's as easy as looking for the direction of the heavier mass. Now, naturally, all the masses will move in accordance to the direction of the greater mass. It's just like saying if I have an inclined pulley this way, and I have a stone here, and then at this point, I have, let's say, a feather here. I have a stone and a feather. Now, if I leave this now, naturally, you would agree that this feather will move in this direction and go towards the direction of the stone. So this system will move this way here. That's an anti-clockwise motion. Now, this is true because the stone is heavier than the feather. So when it comes to picking your direction, it's as easy as, in most cases, taking the direction of the heavier mass. So let's look at the masses given here. Looking down at the question that they said M4 is equal to 6 kilograms. So we're taking down the masses. M4, we said, is equal to 6 kilograms. Next up, M3. M3 is equal to 2 kilograms. M2 is equal to 1 kilogram, and then M1 is equal to 0.5 kilogram. So these are the masses. Also, they gave G as being equal to, that's gravity, 9.8, of course, in meters per second squared. And finally, you're given theta as equal to 30 degrees. In this question, you were not given theta 1 and theta 2. So hence, these two angles are the same thing. So here is 30 degrees, and here is also 30 degrees, are the same thing. All right, so looking at considering our given masses, we can see that the heavier masses is M4, that's this one here, being 6 kilograms. So hence, we said the system will naturally move in accordance to the direction of the heavier mass. So that's M4. So hence, my direction will be this way. So I'll go like this. That's an anti-clockwise or anti-clockwise direction this way. So the system will move this way. Why? Because the direction of the heavier mass, or the heavier mass, is this way. So to go this way, and I'm having this. So the first task there is for us to suggest a direction for the motion of the masses, which we've done. That's an anti-clockwise direction. Reason being because the greater mass is M4. So everything will tilt towards the M4 direction. Next, the next one that says, use the information to I. Says, set up the correct equation of the forces acting on the system. So number one, let's set up the correct equation for the forces acting on the system. All right, so first things first, from our previous classes, we said for M4, that the weight of M4 will be acting down here. That will be equal to M4 times gravity. For this one here, weight of M1 will act downward. It becomes M1 times gravity. All right, so we have this. So we're starting from this one here, M4. For M4, while this is pulling down here, this is going upward. The tension here will be going upwards. If you look at the diagram there, the diagram here was given as T3. So this was given as T3. So this is T3 here. Next up, so we'll pick up M4 first. Let's start with for M4, for mass M4. For mass M4. All right, for M4, let's get the free body diagram of M4. We are having this. So you're having this one here. This becomes coming down this way. The weight of M4, which is mass of M4 times gravity. This is M4. Okay, going up there, we have T3. So I'm going up here, I have T3. So I have this. All right, so let's resolve this. First things first, let's get the direction of motion. We said this is coming downwards like this. So that's going down this way. And hence, this is going down like this. So for M4, my direction is downwards. So hence, I'm taking a downwards direction. All right, from our equation, we said the summation of forces is equal to mass times acceleration. Of course, this is from Newton's second law of motion. If this is true, then for this, it means that let's get the direction of motion. So let's get the sum of forces. So the sum of forces for F, let's say F4, okay, is equal to sum of forces. We said if the force is going towards the same direction, it is considered positive. If it's going in the opposite direction, it's considered negative. This one here is going in the same direction as the motion of the system. So this becomes positive. I'm having M4G. This one here, T3, is going in the opposite direction of the system. So it becomes a negative. So minus T3. So we have this. So I'm having M4G, same direction, minus T3, because it's going in the opposite direction. So we have this. We said this is equal to MA. We write MA in terms of M4 because the mass here is now M4. It becomes M4A. So hence my equation is M4G minus T3 is equal to M4A. So here's my equation. Perhaps we could make T3 subject of the formula. It's as easy as if I move minus T3 over here, becomes positive T3. This one is positive. Move it over here, it becomes negative. In a simplified form, we can say just swap these two. So it simply means that if I move T3 here, it becomes T3. So hence I have that T3 is equal to this one here. That's M4G. This one comes and becomes minus M4A. This is mathematically correct. Call this your first equation. All right, so we are done analyzing for mass M4. Let's now look at how to analyze for mass M3. Okay, so for mass M3, we have this one here, M3. So we'll just draw this like this. Here's our mass M3. So this is mass M3. So let's say for mass M3, for mass M3, what have we got? So for M3, you have this one coming downward. So we're having this direction like this. Of course, this one to also be in opposite direction. We've discussed the idea of these directions in our previous classes. All right, so this one down, this one up. So what do we have? So coming down here, I have this. This would be, of course, this one here is the same rope. If you look at this now, this string like this is the same string. All right, so this becomes the same tension. That means tension, this is one string going from here this way, like this, is a single string. That means the tension in this string will be the same thing. In other words, if this is T3, here also becomes T3 also. So the one coming downward, M3 pointing downwards is T3. I'm having T3. Also, this one is going this way here. Observe that this string starts from here and stops here. Also, this other string starts from here, moves this way and stops here. So this string and this string are not the same thing. So they cannot have the same tension. So if this is T3, we'll now call here T2, signifying that it's a different string. And of course, if you check the question, it's the same thing that was given. So I have T2 going upwards, perhaps. I'm having T2 this way. All right, we are done with the forces acting on M3. Our next task is to consider direction. The direction is like this, that's downwards. If you observe, the direction is going in the same sense or in the same direction as T3, that's pointing downwards. So I'm having this direction this way in the same direction as T3. So direction of the system is same thing as direction of T3 like this, you can see. So I'm having this one coming downwards here. All right, with the same concept as this, we'll say the summation of forces is equal to MA. So I have that, from this I'm having that the summation of the forces on mass 3 is equal to, this is coming downwards and this is coming down in the same direction as this. So it becomes a positive, same direction, positive. So I'm having T3. T2 is going in the opposite direction of the system. So it becomes negative, showing opposite direction, is equal to, write this now in terms of M3 becomes M3A. So we have M3A. So from that now, we can now pick up this equation that T3 minus T2 is equal to M3A. So we have this. So perhaps you can choose to make either T3 or T2 subject of the formula. Perhaps since we made T3 subject of the formula here, let's also make T3 subject of the formula here. From here, it means that T3 is equal to, this is M3A minus T2 comes and becomes plus T2. So we have this equation. Let's call this our second equation. All right, so we are done analyzing mass M4 and M3. Let's now analyze mass M2. So for mass M2, for mass M2, what have we got? First of all, draw the mass M2. So I'm having the mass M2 here. This becomes M2. Obviously, one string, join it upwards, and one string, join it downwards. Okay? One string upwards, one string downwards. Now, next up, let's look at the direction of motion of the system. Now, this was going this way, all right, this way. Join this as regards to M2, it will be this formula like this. So it's more like it's an upward formula, or an upward direction. But before then, we said the tension, this is one string, this string is passed around this. Meanwhile, let me state this please. These are called support systems. Okay? These are called roller supports. All right? The function of this roller support is to reduce the friction on the string so that the string will not cut easily. All right? So these are called roller supports. So back to our question, we said this one here is the same string. So if the tension here is T2, this one will go in this direction and also be T2. So for M2, T2 is pointing upwards. So I'm having here as T2 pointing upwards. And if I look at this here, this is another string. So I have string T3, this is one string, string T2, another string, string T1, a third string. T1 will be in the opposite direction, that's this. So I'm having T1 pointing downwards. All right, so T2 going upwards, T1 coming downwards. So here becomes T1 going downwards. Now observe that the direction of motion of this system is going this way as we agreed earlier. So hence I'm having this motion. So this motion now means that the direction now is going in accordance to the T2 direction, that's upwards. So for the mass M2, my direction is now here. So this becomes this one here, going upwards with T2, as we said there. All right, using the equations of motion, we said the sum of the forces is equal to MA. So if that's true, it means sigma F2 is equal to, we said if the tension is going in the same direction of the motion of the system, it becomes positive. That means T2 will be positive as it is going in the same direction as this, so it becomes positive T2. T1 is going in the opposite direction of the system, so it becomes a negative T1 is equal to MA in terms of M2 becomes M2A. So we have this. All right, so if this is true, from here, if we pick out these two, it means that T2 minus T1 is equal to M2A. For this, depends on which of them you want to make subject of the formula. From here, we can say, so here's our equation actually, but let's see if we can make, since we have T2 here, let's see if we can make T2 subject to the formula here. That means T2 will be equal to M2A minus T1 comes and becomes plus T1. That gives you your third equation. So I've gotten equation 1, equation 2, and equation 3. Our final task is to analyze mass M4. All right, so I'll have to clean this. So let me get down these equations because they are very important. So I'll get down the equations somewhere first before I clean up. So from this, we have that T3. So T3 is equal to M4G minus M4A. We said T3 also is equal to M3A plus T2. We also said T2 is equal to M2A plus T1. All right, so these are three equations. Now I can take this one off and proceed with my solving. All right, so let's get for mass M1. So for mass M1, for mass M1, what do we have? For M1, we have your mass here. So this is M1, mass M1. Coming downwards is M1G. You can see here. Going upwards, we said this is a single string or a single rope. So the tension in this string becomes the same thing. Same thing. So here becomes T1, the same tension. So going up here would be T1. So I have T1 here. All right. So having done this, what's next? Let's see how we could possibly get our direction of motion of the system. The system was going this way in an anti-clockwise motion. So hence, it will be this way up like this. So up this way and then this way down to this point. So hence this is going upwards. I should draw it here. So upwards, we said our next task, summation of forces is equal to mass times acceleration. Let's get sum of forces. As sum of forces is equal to, we said if this force or the tension is going in the direction of the motion, it is positive. So hence T1 will be positive. So I'm having T1 positive. M1 is coming downwards, which should be negative. So it becomes negative because opposite direction of the motion of this system becomes M1G is equal to MA. Writing M in terms of M1 becomes M1A. So if I pick out this equation, it means that T1 is equal to M1G, T1. So it means that T1 minus M1G is equal to M1A. So here's perhaps your fourth equation. All right, so I'm done getting my equation of motion of the system. What's the next task there? Let's see the question. The first part was to suggest a direction, which we've done. The I part said set up the correct equation of the forces acting on the system, which we've done. We set up the four equations: equation 1 here, equation 2, equation 3, and equation 4. So we're done with this. I says resolve the tensions T1, T2, T3, and the acceleration A in the string quantitatively. So let's get the value of T1, T2, T3, and A. So how do we get that? The idea is very simple. Simply try to equate each of the equations and see how they can cancel out. For instance, from equation 1 and 2, I have a value for T3. So from 1 and 2, equating equation 1 and equation 2, we have that T3 is equal to T3. T3 from equation 1 is M4G minus M4A is equal to T3 from equation 2 is M3A plus T2. So we have this equation. So we got this by equating equation 1 and 2, that's the value of T3. Next up, we are seeing T2 here. Let's try to replace T2 by masses. If I look at equation 3, that's this, but from equation 3, we have that T2 is equal to this M2A plus T1. I'll replace this value here. That means I'll be having this equation as M4G minus M4A is equal to M3A plus T2. The value of T2 is this one here, so it becomes plus. In place of T2, I'll write this. It becomes M2A plus T1. So I have this. So final task, let's see how we can take off this tension. Let's see how we can remove this tension, T1. I have a value for T1 here from equation 4. From here, we can say that T1 is equal to this one here, M1A. This minus comes, it becomes plus M1G. I'll replace the value of T1 here. So what do we get? So that will be equal to M4G minus M4A is equal to M3A plus M2A plus T1. T1 is equal to this one here, M1A, that's M1A plus M1G. So we have this. All right, so I've replaced the value of T1 by these two. So we now have this equation. So what's next? Next up, we'll have to take, what's it called? Like terms. So the ones with G would come to the left-hand sides. The ones with A will move to the right-hand side. If that's true, I'll be having here as M4G. Now this one has a G, so I'm moving to the left-hand side. Positive crosses over here, becomes negative, so minus M1G. I have this. And that's equal to, from here, I can see that M4A, which is having A, will move over here, so it becomes a positive M4A. Now, if I move this over here, I can see M1A, M2A, M3A, and then M4A will come here. But just to write it in terms of ascending order of masses, we use M1, M2, M3, and M4. It's the same thing. So it becomes this one first. M1A plus the second mass, M2A plus the third mass, M3A plus minus 4M minus M4A comes over here, becomes plus M4A. All right. So this now becomes our result. I just simply rearrange this one here in ascending order. Nothing changes. All right. If you want to still use it as this one, no problem. But I think it looks better in ascending order from 1 to 2 to 3 to 4. All right. So we have this now. And next time, now need to factorize. So I can factorize G out of this. So if I factorize G out of this, if I take G out from here, I have M4. Take G out of here, I have M1. So I'm having M4, okay, to create space. All right, so take out G from here. I'm having M4, so it becomes m4 minus m1 all multiplied by g. So I have this one here. Of course, if you multiply them, m4 times g is m4g minus m1 times g is m1g. So it's the same thing. That's equal to, and next task would be to factorize the a out of it. So if I remove a from here, I'm left with m1. Remove a here, I'm left with m2. Remove a here, I'm left with m3. Remove a here, I'm left with m4. So that will be equal to m1 plus m2 plus m3 plus m4 all into a. So a times m1, m1a times m2, m2a times m3, m3a, and then a times m4, m4a. So I have this. So let's get the value of the acceleration. To get a, I'll simply have to divide this one here by this one attached to it. That's m1 plus m2 plus m3 plus m4. Same thing here. Divide here too by the same value. That's m1 plus m2 plus m3 plus m4. From here, we can have that this will cancel all of this. I'm left with a. So hence, the value of a, or the equation for the acceleration a, is equal to m4 minus m1 all multiplied by gravity all over the sum of the masses. This one first, m1 plus, next up, m2 plus, next up, m3 plus, next up, m4. So I have this. All right, so this becomes the equation to get acceleration. All right, so fixing the values of each of these and see the value and get the value for a. Before that, I'll have to clean this up. So let me write out this equation somewhere. That's m1. Note this one somewhere. That's m1. Where do I get this in here? So let's see if we can squeeze this here. We said m1 is equal to m1a plus m1g. So these were 4 equations. 1, 2, 3, 4. All right, so we now have this. Let's now impute this value here and get the value of a. Okay, so if you impute values, it means that a is equal to, we said m4 minus m1. m4 is 6. So 6 minus m1 is 0.5. So 0.5 all multiplied by g, gravity, which is 9.8. So times 9.8 all over m1 plus m2 plus m3 plus m4. m1 0.5, so 0.5 plus m2 1, so 1 plus m3 2, that's 2 plus m4 6, that's 6. Work on this math. This is equal to, subtract this 2, you have 5.5 multiplying 9.8, that's gravity, all over, sum this. This gives you 628 plus 1, 9 plus 0.5, that's 9.5 as a value. So that's equal to, multiply numerator with my calculator, I have 5.5 times 9.8, that's about 53.9, yeah, all over 9.5. So 53.9, excuse me, all over 9.5. So acceleration A is equal to 5.67 approximately to 2 decimal places meters per second squared. So I've gotten the value of the acceleration. We are yet to get the value of T1, T2, T3. Yeah. So let's now look for the value of T1, T2, and T3. All right, so we've gotten the value for the acceleration as 5.67 meter per second squared. Let's get the value of T1, T2, and T3. So let's start up with T3, our first equation. We say T3 is equal to From equation 1, T4G minus, sorry, M4G minus M4A. All right, so replace value. That's equal to M4 times G. M4 is 6. So that's 6 times, this is 9.8 minus, this is 6 times A is 5.67. So I have this. Multiply this, 6 times 9.8, 6 multiply 9.8 is 58.8 minus 6 times 5.67, that's 34.02. If I subtract this, T3 is equal to 58.8 minus 34.02. That's about 24.78. Tension is measured in Newton. So that's the value of T3. Next up, let's get T2. We can get T2 from either this equation or this. But we can't use T3. We can't use equation 3 yet because the value of T1 has not yet been gotten. So now use this one instead, equation 2. So from equation 2, they said T3 is equal to M3A plus T2. So let's put this value here. T3 is 24.78 is equal to M3. M3's value is 2 times A. The value of the acceleration is 5.67 plus T2. This gives you 24.78 is equal to 2 times 5.67. That's 11.34 plus T2. So hence, to get the value of T2, I'll move this over here. So T2, hence T2 is equal to this one, 24.78 minus this one, 11.34. So hence T2 is equal to 24.78 minus 11.34. That's about 13.44 Newton. So hence, I've gotten the value of T2. Finally, let's get the value of T1 using any of these two equations. So I'll use both equations to see if my answer is correct. Let me use the equation 3. So from equation 3, they said, or we had T2 is equal to M2A plus T1. So I have this one here. All right, let's get this done. So T2, we said, is 13.44 is equal to M2. M2 is 1 kilogram. So that's 1 times the acceleration, which is gotten as 5.67 plus T1. So this becomes 13.44 is equal to 5.67, of course, times 1 is itself, plus T1. I'll now move this one over here. I have 13.44 minus 5.67 is equal to T1. If I subtract this, I have 13.44 minus 5.67. That's about 7.77 is equal to T1. So we are saying that T1's value is equal to 7.77 Newton. So that's the value for T1. But we have an alternative formula for T1. So we could perhaps test it and see if we can have the same answer. So let's try out our alternative formula for T1 and see if we'll have the same thing. So we have that T1 is equal to M1A plus M1G. All right, input values. M1 we said is 0.5. So 0.5 times A was, acceleration was 5.67. 5.67 plus M1 0.5 plus times G is 9.8. All right, to get this done, this is equal to, so 0.5 times 5.67, that's about 2.835 plus 0.5 times 9.8, that's about 4.9. All right, so combine these values. I have 2.835 plus 4.9. I'm having 7.735 Newton as T1. So if I look at the value of T1 here and T1 here, they are almost the same thing, something around 7.7. So that means the whole stuff is correct. Now, the reason for the difference in value is because of friction. All right, friction somehow is the reason why we have a little difference in tension. Now, in as much as the um, question says that we should, or let me use the question, let me use the term there. The term there says frictionless plane, inclined frictionless plane. That's just hypothetical, all right? In as much as the question says it's a frictionless plane, that's just hypothetical. In a real sense, there has to be friction because this is touching this. So there will be a bit of friction, all right? So, but we're just assuming that the friction does not affect the question. But you can see it affects the question in a real sense. So we can say they are correct. 7.77, 7.735. That's approximately almost the same thing. So we've dealt with that. So we've done number 2, which says resolve the tensions T1, T2, T3, and the acceleration in the string. We've done that. I think that was this one here. That's the resolution here. Then the III says find the numerical values of the tension, which we've just done. All right. So these are the numerical values of the tension and the acceleration. So the acceleration A is 5.67 meter per second squared. T1 is 7 points. I would go with this value instead because this one was the value we got when we were working with the whole movement and all of that. So T1 is 7.77. T2 is 13.44 and T3 is 24.78. That's the value of T3. All right. I think that's it. That's all. All right. So this is how you solve this particular question. See you in the next class. Don't forget I said I will drop the links to our previous classes on frictions in the description of this video. So go to the description, you'd see a link to our previous classes on pulleys, both with friction and without friction. All right then, see you in the next class.